scroll down here, and we see that at this move it from the stack into EAX, we're going to transfer the taint from the stack to the first byte of the register, from the second byte on the stack to the first byte, to the second byte of the register, and then third byte to the third byte. So we do it byte by byte based. Even though the register is 4 bytes wide, we want to actually trace it on a byte level and not on the word level. And then here's the next part where EAX moves back into the temporary, and we have the moving it from the register into memory. So we move the taint from the register to the memory taint. Here's where we're actually going to taint the flags. So this is where we're comparing it to 40 to A. So this is matched up to this conditional right here. And this is X equivalent to A. And because X is tainted, we're going to taint this conditional on the flags with the taint from A. And then when the jump not 0 is taken, we know that those flags were tainted by that, and we propagate that. And then these marks are all created to, whoops. The marks you see are the taint created by the control dependence relation that we calculated. So we know that this jump not 0, or we know that this block here is control dependent on this jump not 0 block. So that anything that gets executed in here is dependent on the value of A, which we've calculated with the taint propagation. Does this make any sense? I'm sort of just going up here and droning, but yeah. Please ask questions. What's that? Okay. I don't do any. I remove the taint. Yeah, then I say the entire thing is cleared. Yeah, I don't want to overestimate what I think I know about it. You know what I mean? I want to be very conservative. Yeah. And I don't do any bitwise, and I don't even have XOR in right now to do the clear. So in my taint propagation, I don't actually clear. So XOR is a special case. So if XOR EAX is going to clear EAX, and it's a commonly used idiom. So it's something we have to put in to be able to say the taint is cleared from that value. Whereas usually if you XOR EAX with some constant value, you'd say the taint is going to still exist because it's just combining some value with some other value. And if the value was already tainted, we want to leave it tainted. But XOR EAX is one example where you're going to have to clear the taint. Same with like sub EAX. Those are things I don't take into account right now. I only have 15 instructions that I do the taint propagation on right now. There's a open source tool, or I don't even think it's open source yet, a tool that will soon be open source called Dion from the Georgia Tech people, and Vincenzo Iozzo is actually working on it too. He gave a talk at Black Hat about using it for fuzzing. Dion, D-Y-T-A-N. It's from, just Google Dion and Georgia Tech. Anyone have any other questions while we're here? How does it handle a call through a pointer? You do not, so you can't just go tainting everything that comes after that. I've been considering ways to do this because a lot of parsers will have large switch statements, and those switch statements are, the jump tables. And to calculate the address for the jump table, you're going to use this tainted value, and you need to say that, okay, this is actually dependent on that. So right now it doesn't exist in my tool. I mean, it'll just not say that's untainted. It won't follow the control dependence. But that's something that I think you'd want to add as a special case because it's something you'd find quickly in the binary, and you'd want to say that the taint would propagate that way. It just doesn't do it yet. Another thing that I've been thinking about, but that I haven't done yet, is self-modifying code, or like JIT code, because we can't do all the static analysis beforehand. You'd have to record the stuff that gets executed, which you do with the trace tool, and then put it back together and do your analysis afterwards, or just in time itself. You couldn't do it beforehand in the database like I'm currently doing it. Yeah. Well, since you have everything available, it's actually the logical address, so or the virtual address. So if EBP plus 4 equals ESP or whatever, then yeah, it's fine, because it's actually the address, not. Does that answer your question? I think that's what you're asking. I'm not sure. Yeah. Any other questions about this stuff here? Okay. So this, the other cool thing about this is that the nav bar up top will get colored based on where the taint is, so you can quickly jump to where you want to be. And the other thing I'm trying to integrate is what's the Java parser generator called? Can't remember. What is it? Antler. Yeah. Thank you. Antler has a really nice parse tree representation that I'd like to steal from them in their Antler Antler development tool. It draws it really nice and it represents it really well, because the tree I use right now is not optimal. I mean, it doesn't represent both repeatable pieces and a hierarchy, like breaking down an atom into multiple, like a non-terminal into multiple terminals and then non-terminals. But Antler does a really good job with that, and I think that's probably where I'm going to end up, either stealing theirs or making one just like it. If anyone's seen that, I don't know. Okay, where were we? There's something else I wanted to cover. So the whole point of this BaSO4 was to eventually get to the point where we could do multiple traces at once, not at once, multiple traces in a row, and then correlate those. So we say that in this trace, this bit of code always parses out the blink tag, but in the second execution, it always parses out the paragraph tag. And so then you know that, okay, what you marked as part of the code that actually processes the blink tag is wrong. And if you run this on increasingly larger sets of data and increasingly more complex pieces of input, then you'll be able to come up with like a probabilistic coloring of your of the IDA shading. That way you have like a light blue would say like, okay, it might be tainted, we're not sure, and the darker blue would be, okay, in every execution we know that this always processes this type of data, and it's easy to see. That should be not too bad to do, but I haven't done that yet either. And then the other thing is this control dependence data that we have. Right now I'm throwing all the colors, like the taint based on control flow, the taint based on just data being moved, and then things like the guy over here asked about tainting based on indirect jumps. All that sort of gets lumped in together. It'd be nice if you could turn on and off different types of taint and like we were talking about before, add sort of hints, because as you're auditing, you get a better idea of how things are working, and you're a lot smarter than the computer usually, so you can add those there. And I think that's everything I have. Yeah. Yes, right. Yeah, that's not at all. That's right. That's the other thing I